This is a video recording walking through our recent underwater 3D sonar collection of the Stillwater lift bridge, focusing at Pier 8 for the Minnesota Department of Transportation Bridge Hydraulics Unit. This is an aerial photo of the Stillwater lift bridge, bridge number 4654. On the right-hand side of the screen, you can see the Wisconsin approach, or Houghton, Wisconsin, and on the left side of the screen is Stillwater, Minnesota. And then the lift bridge section is in the center of the screen. This next shot is an old bridge survey sheet from the bridge 4654, the lift bridge. And on this sheet, you can see the location of the previous structure to the south or downstream. And that could potentially be important because some of those old structure was also noted in the underwater inspection and the underwater sonar that we took. This is a general plan and elevation view of the lift bridge. You can see Pier 1 on the on the Minnesota side, the western side, and Pier 8 and 9 over on the Wisconsin side, the eastern side. This is just a historical photo of the bridge right after it opened in 1930. This bridge is a historical structure. It's on the National Historic Registry, and I have a number of historical photos just to take a look as we move forward. This is a picture of the previous structure. It's a pontoon structure with open trestle sections that you can see spanned the St. Croix River or Lake St. Croix at this location. And there was a number of piling and trestle work that was in the river from that old previous structure. Here's a picture of the approach being built from the Wisconsin side, that causeway that comes out from the Wisconsin side. This is another interesting photo from the construction of the lift bridge. You can see all the trestle work that they had to put in order to build this structure, and there is a number of those old piles that were left in place or not cut off low enough and are showing up in the underwater sonar. Another historic photo just of the pile driving again, and then the photo to the right is a picture of the pier being formed, one of the piers being formed, and you can notice the sheet piling down at the bottom. That will actually be noted in one of our underwater inspections and then also in the final 3D scan that we show. This is just some of the previous technology that we had to take a look underneath the water at the piers. This is the 2013 underwater inspection. Again, we're going to be focusing on Pier 8. That's our final product that we'll be looking at. As you can see, there was a depression noted at the upstream nose of Pier 8, so the north face, and a slight one noted at the downstream face as well, and that footing was exposed all along. You can read in note 5, the footing at Pier 8 was fully exposed along the entire perimeter of the pier with 4 feet full footing height of the vertical exposure, and this seal was exposed at that northern face. This is an example of some previous mapping that we did with our single beam sonar. In October of 2006, was mapped with an Odom Digitace depth sounder and got a pretty nice contour map, but just is lacking a lot of the detail right around the piers in particular. Especially as we go underneath the bridge, we would potentially lose GPS signal. So a nice tool, but doesn't really complete the picture at the piers. The sonar unit that we used was a Teledyne Blueview BV5000 3D mechanical scanning multi-beam sonar. Our unit was a 1350 kilohertz unit. It has 256 beams with a 45-degree view, so that's the cone. It can tilt up and down and pan all around 360 to get basically an entire 360 view. Typically that is deployed off of a tripod. As you can see in this photo, there's a pan and tilt unit that sits on top of the base of the tripod, and then the sonar head is inserted into that pan and tilt unit. We used a number of deployment methods for this bridge, and I'm going to be going through each one of those. This is our standard tripod drop. One of the problems with the tripod, although it actually gets a pretty nice picture, if you haven't scanned there before or you're not real familiar or don't have very good visibility in the water, which is pretty typical on most of our rivers, you can potentially get the unit stuck in debris. So our unit did get stuck. Luckily, we were performing these scans with Collins engineers, and they were commercial divers along with us, so they were able to go in and get it out, and they were successful in doing that. A couple of our alternate collection methods. We have steel plate that was manufactured by our Mankato bridge crew to mount that pan and tilt unit right on the steel plate, and then the sonar head would go on top of that pan and tilt unit and get a much lower profile look for this, and pretty heavy duty. And then another view that we could do from the top down off of the boat, which is a very useful view and actually ended up being the most efficient, is a pole mounted unit where the pan and tilt and sonar is mounted onto a plate that's directly mounted to a pole off of the boat. This is a final view of the underwater scan that we took at Pier 8. It's actually a number of scans that were stitched together. We did the processing in 3 separate programs. Cyclone, we did most of the cleaning and the final registration by Leica Geosystems. Quick Stitch by Teledyne Blueview is where we did most of the translation and the initial registration. And then Cloud Compare, which is an open source software program, which is what's upstream, mostly just to do the rendering and illustration. So we're going to pan around out here a little bit and take a look at the final 3D scan. You can notice on the lower left-hand side of the screen, that is the upstream or north face of the pier, and there is a scour hole created by Pier Scour at that pier. You can see the sheeting that was noted in that original picture. A lot of debris in some of the piling, so it gives you a really great picture. There was also some undermining that we noted and were able to capture, at least to a certain extent. Unfortunately, we couldn't get right underneath it because of the location of the debris. We did do this particular pier with all 3 methods. Where you see the holes in the scans, those are where the tripod drops were. Then we came back in and filled in afterwards with a top-down view. So around the front upstream and downstream nose, we got a top-down view to fill in those voids and fill in some of the holes that we couldn't see before, and got a really nice picture of that front face of the nose. And then because we had that scour hole, felt it was necessary to do a plate drop as well to be able to fill in and see where that undermining potentially would be. The pier is actually in fine condition. In terms of scour, that hole has been noted in all of the underwater inspections for the previous probably a dozen years and hasn't changed significantly. So it's just another watch item for future underwater inspections, but otherwise is as expected. You'll also notice another depression just downstream of the pier. As you recall, there is a causeway coming out from the Wisconsin side, which is over on the left-hand side of the screen, and that likely is causing some form of contraction scour just downstream of the bridge. We see this as being a very useful method for data collection, especially in low visibility, difficult geometry conditions, certainly in dangerous diving conditions, and to be able to see where those debris and other hangups could be. And typically we would use this for scour assessments or monitoring as-built for new bridges or for repairs, potentially for structural assessments, especially as a way to enhance the underwater inspection program. And really the final say on it is that a picture is really worth 1,000 words. You can't really just get this kind of description from either single beam sonar or from an underwater diver report.